Hello, Calculus. Coming back at you guys with some more Trig review. Covered some loose ends that I know we didn't get to cover a whole lot last year with you guys, but this should be a good Trig review for you, so or at least help you out. Now, sometimes you're in trigonometry, you're given something called an identity, which is something that is always true, and so you want to verify or prove that this identity is true using known identities. And that's where your identity sheet will come in. If I scroll over here real quick, I could probably see the identity sheet here. So these are the identities we're going to be using here to be proving that these ones indeed are true as well. So we're trying to verify this. Well, let's see. When we verify, I like to divide the equation into a left and right side. And what I typically recommend is starting with the more complex side and working it down to the simpler side. So I'm going to work strictly on this side here. And I'm going to see if I can work down and I can arrive at sine squared of theta down here. All right, well, let's start here. If you recognize, if you're looking, secant squared of theta minus 1 is actually equivalent to the tangent squared of theta under your identities. If you scroll over here, let me see if I can show you that. Right, and under this, let me look this real quick. Under this identities right here, what you have is you have this one right here. This is where I'm looking, right? I'm looking right here, and don't pay attention to the variable. X can be changed to theta. It can be changed to u. You know, these x's, they're just dummy variables. You can change them to whatever you want. So look over here at this. And let's see if we can manipulate it, right? Well, if I subtract 1, you know, I'm going to get secant squared of theta minus 1 is equal to tangent squared of theta. And I turned it into a theta. It doesn't matter. And that's what I'm going to substitute over here. So if I just move over just a little bit to bring this back in here, what you'll have then is you're going to have tangent squared of theta on top, secant squared of theta on the bottom. Now, once you make that substitution, you're keeping your mind on the goal here of sine squared of theta. You have to get this down to a sine. So what I would do is, if you can, transform tangent into a sine and a cosine, and secant into a cosine. Well, if you look here under tangent, quotient identities, you're going to see that if I square this side, that's going to be equivalent to this squared. So squaring both sides produces a new identity here. Well, so that numerator is going to become sine squared of theta over cosine squared of theta. This is all over. And secant, if you look up here, secant, right, is 1 over cosine. So I have it squared though. So if I square this side, I square this side, 1 squared is 1. This will be squared. So this is another identity that's true. So I'm going to end up with 1 over cosine squared of theta down here. Now let me move this out of the way just a little bit. I can still drag that. Okay, what's going to happen now is, remember, division by a fraction is the same as multiplying by its reciprocal. So if I take sine squared of theta over cosine squared of theta, I'm going to times that by, let me erase this here, hold on. I'm going to times that by cosine squared of theta over 1. And what's going to happen is, guys, this is going to cancel with this. And what you'll see is you are left with sine squared of theta. Okay. What I like to do is you make some type of statement at the end here. Once you finish, you say, therefore, the left-hand side does indeed equal the right-hand side. So we've proven it. So I've verified this identity. I've taken this, I've worked it down and showed that it is indeed equal to sine of theta, which is what I wanted. And that's how you verify an identity. This is just one organizational way to do it. Mathematicians will organize things differently, but this is one way that I like to work down through these. Now let's look at another one, and I'm going to move some things here if I can. Hold on, let me check my identity sheet here. Okay, edit. That's what I want. Okay. So let me scroll over, and I want to look at another one. And let's actually pull this one out of the way a little bit. Let's get this one on the screen. And let me see if I can Here's a little identity sheet we can work with over here. So let's put that in, okay? So, all right, let's work on this next one. And again, I'm gonna work down. So I'm gonna take this, I'm gonna divide it in half like this. I wanna verify, again, I wanna verify that this is true. So what we're gonna do is you're gonna try to simplify this complex side over here and get it to equal this side over here. So let's see what we can do. If you recall our fraction pattern, I'm going to take this, times it by this 1. I'm going to take this and times it by this 1. And I'm going to times these two together. What I'm going to get is 1 plus sine, that's alpha, plus 1 minus sine of alpha, all over, that's the difference of squares. It's going to be 1 minus sine squared of alpha. All right, when you FOIL those together, remember we're multiplying each of these up here. So this is times 1, this one's times 1, and then these are times each other. So that's where we're getting this. Now notice up top, the signs will cancel out. You're gonna be left with 2, which is nice because that's kind of what we want. 1 minus sine squared, if you look over here, right? If I subtract my sine squared to this side, I'm gonna end up with cosine squared. So this is cosine squared of alpha. Now, notice what I can do is this 2 can come out front. It's times 1 over cosine squared of alpha. Well, guys, 1 over cosine, let me look through here. I'm trying to find 1 over cosine. It's right here. 1 over cosine is equal to secant. Well, if I square that, it's no different. I mean, it's going to be 1 over cosine squared is secant squared. This is just 2 times secant squared of alpha. So what happens is I worked down, and I actually got 2 times secant squared of alpha. And so I say something at the end like, therefore, the left-hand side does equal the right-hand side. All right? So there we go. Scroll down, and let's try to work on another one. So to go through, and hopefully we can start to get a pattern or, just something that we can do this. Let's do this one. Let me get this set. Okay, so again, I'm going to take this and, I'm going to draw my dividing line. And I'm going to work on the left-hand side right here and try to get it over to this side. I like to work on the additions and combine them together. Let's try it. I know tangent, if I'm looking over here, tangent is this. I know cotangent is this. And actually, I'm going to do that. I'm going to turn them into sines and cosines. That's one trick you can do if you have nothing else to do. Just turn them into sines and cosines and then work with those and see what you get. All right, now, what I'm going to see, let's go down here. Let's grab this one. All right. So doing your cross pattern here, again, this comes up, multiplies by this one comes up, multiplies by this, and then these two multiply together. So to get to do that, that's sine squared of x plus cosine squared of x all over cosine of x times sine of x. All right, well, immediately my mind is drawn over here back to this Pythagorean identity where sine squared of x plus cosine squared of x equals 1. That top is just a 1. Kind of cool. And it's cosine of x times sine of x. Well, guys, you can separate those out. That's 1 over cosine of x times 1 over sine of x. Now, let me just move down just a little bit here. Guys, 1 over cosine. Look up here, 1 over cosine, right there again in that box. That's secant. Times 1 over sine. Well, 1 over sine is right here. That's cosecant. There you go. We've proven it. Look, right there. That matches this. So we say, therefore, the left-hand side equals the right-hand side. All right, so you're working through trying to prove it. We did. We simplified this down. We showed that this left side equals the right-hand side. That means this identity is true. The rest of your life, if you see secant of x times cosecant of x, you can replace it with tangent of x plus cotangent of x, or vice versa. So that's what the nice thing about verifying identities is once you do it, you can just use that the rest of your life. It's crazy.